Holla, holla, and what's up to you all great 10 Mindsetters? It is a lovely Monday, our Triple M day. It means Mindsetters Maths Monday with me, Abram, and you know we are with Natasha. We are about to learn more and learn extra. Natasha, how are you?
I'm very well, thanks, AB, and looking forward to the World Cup, guys. I hope that you all started the countdown.
Exactly. It's the same feeling we had when it was in South Africa. We should do the same, hey?
It's difficult, though. When it was in South Africa, it was so
When
special.
it's at home. But I think we should still support. Otherwise, how was your weekend?
It was all good, AB, and working hard for you guys at home. We're going to do some geometry, so I had to get all of that ready for you guys, and we're going to start our lessons on geometry starting today with Midpoint Theorem.
Ah, guys, you see what our teachers do though on weekend. Thank you so much, Natasha. Well, my sisters, welcome to it. I hope you're up and ready to learn more with this. Chat with me on facebook.com/learnextra. Like the page, share the page. I just want to know, how was your maths class today? Grade 10s. Did you enjoy it? What were you guys doing? And if you're writing some tests, also share how did you write, because I know that some of you are still writing. So let me know on Facebook, how was it? And also on Twitter, you can tweet us at learnextra. But now, since it is a lovely Triple M day, we have more maths. All you need to do is to go to moremaths.org, and your code is 2FB5. 2FB5. That's your code. Register and challenge yourself and challenge other Mindsetters. Rank yourself and see. On what we're doing today, you're also going to get some questions there on More Maths app. So it's a cool, fun app. All you need to do is to go to moremaths.org. That's it. And for today's show, we've got the view notes and the download notes links on Facebook. So all you need to do is to go to Facebook and then check them out. We're also going to give you the test yourself link, whereby if you fill in the right answers, you stand a chance of winning this awesome Casio calculator. So all the best. I'll be announcing last week's winner right here on Learn Extra. So stay tuned. We're about to learn, and Natasha will tell us more about the challenge question also.
All right. Okay, guys, so today we're looking at the midpoint theorem, and specifically we're going to look at the application of that theorem. Your challenge question for today, based on the application of the midpoint theorem, you are told that PQR is an isosceles triangle with PR equal to QR. So they give you that those two lengths are equal. S is the midpoint of PQ. So S is the midpoint of PQ. So if we can put little marks there, those two are equal. T is the midpoint of PR. All right, we're going to run out of shapes quite soon. And we are also told that U is the midpoint of RQ. Okay, so we've got all our little equal line segments. You are then asked to prove that triangle STU, which is the one in the middle here, prove that that is an isosceles triangle. So it may seem challenging at first, but if you understand your midpoint theorem, and hopefully by the end of this lesson you'll understand it even better than you do right now, if it's just a straightforward application of that, you will have absolutely no problems with this. All right. Okay, AB, I think we're ready to start the lesson.
Okay, let's do this, because the challenge question is already on the page.
All right, guys. So the midpoint theorem, well, generally, when we look at geometry, we're talking about Euclidean geometry. What we do is we use a set of logical deductions to arrive at some sort of conclusion. So if you find that you are a very logical person and you've got no problems putting 2 and 2 together, then you're going to have no problems with geometry, because it really is a section that just enhances and tests your logical reasoning, your patterns of reasoning. Okay, I absolutely love geometry, one of my favorite sections. Hopefully you guys are going to enjoy it too. So what does the midpoint theorem say? It says that the line joining the midpoints of two sides of a triangle is parallel. So I'm going to draw a triangle here. Let's try a little bit of a better triangle. There we go. Okay, so we've got that triangle there. And here we've got the line joining the midpoints of two sides of a triangle. Okay, so say that's your midpoint on this side and that's your midpoint on the other side. That line is parallel to the third side of the triangle, and that line is equal to a half of the third side of the triangle. So whatever the third side of the triangle is, this line that joins the midpoints of the triangles together, that line is going to be a half of whatever that distance is. Okay, that's just what the theorem says. You are expected to understand this theorem, to know this theorem, and apply it. Okay, that's literally all the summary I can give you as far as what does the midpoint theorem say. You obviously need to know the proof, which is in your textbooks. You can learn that proof, but we are just going to be looking at applying this theorem. What does it do when it's in action? Okay, so straight away what I want to do today is start with some examples. So here we are asked firstly to find x and y in the following triangles. Now let's look at triangle A, or the triangle in question A. Okay, you see that you've got the midpoint given on this side of the triangle. You know, these two little signs indicate that that line segment is divided into two equal pieces. And then we've got the same thing there. We've got the midpoint of the other side of the triangle. So we see that there's a line joining the two midpoints of those sides. Therefore, we know from the midpoint theorem that that line must be parallel to the third side. And the other bit, what does it say? That line must be a half of the third side of the triangle. So therefore, x is going to be equal to 2 times 7, because from the midpoint theorem, okay, and that's just a straightforward application of the midpoint theorem. From the midpoint theorem, we know that the line joining the midpoints of the two sides is a half of the side of the length of the third side of the triangle. So therefore, if this line is 7, that means that the other line, the third side, must be twice that value. So therefore, x is going to be 2 times 7, 14. Okay. All right. Similarly, as you can see, these are straightforward applications of that theorem. Understand your theorem. No reason to get these incorrect. We've got exactly the same pattern. We've got the midpoint on one side of the triangle, midpoint on the other side. We've got a line joining those 2 points. Therefore, straight from the midpoint theorem, we know the line joining the midpoints of 2 sides of a triangle is parallel to the third side and a half the length. So x will therefore be a half of 7. And again, that's just because it's the midpoint theorem. That's what it says. And a half times 7 is 3 and a half. Okay, guys, that really is a straightforward application of this theorem. I'm not going to go into too much more summaries or details in the beginning to get this going, because we do have a lot of questions to work through. So I just want to kick off with a quick summary. What does the midpoint theorem say? Hopefully you all know what it says now, and a straightforward application. When we come back from the break, AB, we will do a few more examples, and they'll get a little bit harder.
Awesome. I like that. Do chat with me on facebook.com/learnextra. Post your questions and help one another on the page. And also remember, we do have the challenge question and it's posted. We need your answers, guys. Work with us, and then we'll see your answers later. Welcome back, guys. Now, exciting news are when you go to learn.mindset.co.za, you're going to get a fresh new feel of our website. So, guys, do check it out and let me know on Facebook, how does it look? Does it make things easier and simpler for you? Because when you just go to the tabs there, if you go to the website, have you checked it out, Natasha?
I haven't. Let me have a look.
You should. Look at this.
Let's see what it looks like.
You go to learn.mindset.co.za.
Fantastic, fresh colors, hey?
It's fresh, it's alive. And the nice part of it, if you go to a tab that is called Learn Extra, guys, there are 3 links there. There is a Learn Extra Live, Learn Extra Lessons, and Learn Extra Revision. So it simplifies everything. When you go to Learn Extra Live, you also get a link that makes you to jump straight to the schedule. So you don't need to look for the schedule. Where's the schedule?
Looks fantastic.
Jump straight to the schedule.
Yes.
So guys, all the notes are there. Make sure that you go to the website. I'll also give you the link on Facebook.
All right, guys, so we're back carrying on with midpoint theorem. We're looking at application of that theorem. Make sure that you understand that you guys understand what the theorem says. As I said before, geometry is all about logical deduction. So you make a statement, you need to have a reason. You cannot make a statement that doesn't make sense. So whatever information you give us as your answer, it needs to have a logical reason for why you put down that answer. Okay, so question 1. We've got triangle ABC is right angled at A. D is the midpoint of AB. So as you can see, we know that that means that AD is equal to DB. DE is parallel to BC. And FD is perpendicular to AB. All right, so we've got the midpoint of line AB. We know that DE is parallel to BC. That's what they gave us. The first question says, prove, giving reasons, that AE is equal to EC. So prove that AE is equal to EC. So let's write down the proof for part A. All right. So we know from the given information, we know that AD is equal to DB. Right, and as I said, every statement needs to have a reason. This is a very straightforward reason that was given to us. So AD is equal to DB, that was given. We also know that DE is parallel to BC. That was also given to you. So therefore, you've got a line that's joining the midpoint of one side of the triangle to another side of the triangle, and you know that that line is parallel to the third side of the triangle. Therefore, it stands to reason if AD is equal to DB and DE is parallel to BC, logical deduction, therefore AE must be equal to EC because that's what the midpoint theorem says. Okay, the line joining the midpoints, only the line joining the midpoints of two sides of a triangle will be parallel to the third side of the triangle and equal to half of it. So therefore, AE is equal to EC, and your reason here is midpoint theorem. All right, so that's a very, very straightforward one, and just showing you how you should, giving you an idea of how you should set up your proof in geometry. You start with your statement, and then your statement is followed by a reason for making that statement. All right. Next part says prove that DF is parallel to AC. Now, before we do that, I want to remind you guys that geometry, I mean, every section in maths is like that. It's building blocks, but geometry especially so. You cannot just forget about anything you've learned in geometry. Simple things like you've learned angles on a straight line add up to 180 degrees. You're going to be using that over and over again. Co-interior, corresponding, alternate angles. Remember, parallel lines, the angles that are formed between those parallel lines, they come up continuously. You need to know all of your basics from geometry to answer questions all the way through to grade 12. So such an example is part B, where it says prove that DF is parallel to AC. So they want us to prove DF, that one, is parallel to AC. Okay. Now guys, if you look at what you're given, they told you that angle A is 90 degrees. They've also told you that DF is perpendicular to AD. Therefore, if those two angles are equal to each other because they're both equal to 90 degrees, what do you see? What type of angles are those? Well, it forms, remember from grade 9, your fun diagram, right? It forms an F shape, so therefore those angles A and D are called corresponding angles. And we only get corresponding angles being equal when the lines are parallel. So we say angle A is equal to angle D is equal to 90 degrees. Okay, but these are corresponding angles. All right, so therefore if these are corresponding angles, therefore it stands to reason, logical deduction, DF must be parallel to AC. All right. Nice simple proof for that part B. Part C says prove that BF is equal to FC. So we're making this diagram very, very colorful. We've got BF and there's FC. So in other words, they're asking you to show that F is the midpoint of BC. So how do we do that? Well, let's analyze what we've just done. We've just proved that this line, DF, is parallel to AC. Okay. We also know that D is the midpoint of AB. So therefore, if we just cast our eyes to everything that's drawn in green, all right, D is the midpoint of AB. We know that DF is parallel to AC. Therefore, logical deduction from the midpoint theorem, it implies that F must be the midpoint of BC, because this line DF is the line joining from the midpoint of one side of the triangle parallel to the third side. Therefore, F must be the midpoint of the opposite side. So let's write this down. Okay, so we know this is part D. All right. We know that D is the midpoint of AB. All right, that was given to us. We have just proved DF is parallel to AC. Therefore, that means that F must be the midpoint of side BC. So therefore, BF must be equal to FC, and that's just a deduction from your midpoint theorem. All right. Okay, and I'm sure by now you guys are looking at this and saying, but this is so easy. Yes, it is. All it is just an application. Understand your theorem. Straightforward application. You shouldn't get this one wrong. Shouldn't give you any worries at all. All right, this is now part 2, question 2. Okay, and in this one, we are given that AC is parallel to MK. And in triangle LMK, LA is equal to AM. So all of the information that you're given is depicted in the diagram. All right? So let's have a look here. Firstly, they say prove, giving reasons, that B is the midpoint of LN. So prove that LB is equal to BN. Okay, so let's analyze. What do we have? We know from the given information that AC, the whole of the length AC, is parallel to MK. Okay, we also know that A is the midpoint of LM. Therefore, before we write anything down, we can already see it's similar to the other ones we've done. If B is the midpoint, if A is the midpoint of LM, okay, A is the midpoint of LM, we know that AC, that whole line, is parallel to MK. Therefore, a portion of that line segment, AB, will still be parallel to a portion of the other side. So therefore, AB will be parallel to MN. So if A is the midpoint, AB is parallel to MN. That means that B must be the midpoint of LN. Okay, but remember, it all comes down to how you write it down, because even if you understand exactly what the question is saying and how you need to go about it, if you don't write down the correct proof, you're going to lose some marks. All right. So how do we start? We know that A is the midpoint of LM. LM, and that was given. Okay. We also know that AC is parallel to MK. That was given. Therefore, the little portion of that line segment, AB, must be parallel to MN. Okay, so if the whole line segment is parallel to each other, then obviously little portions of those line segments will still be parallel to each other. So we know AB is parallel to MN. We know that A is the midpoint of LM. Therefore, this must mean that B is the midpoint of Ln. And why can we say that? Well, simply because it's exactly what the midpoint theorem says. Okay, so we have identified one midpoint of the triangle. We've identified parallel third sides. Therefore, it stands to reason that the other side that AB is connecting to, that side, must be the midpoint of Ln. Right. Similarly, if we look at part B, it's saying prove that LC is equal to CK. So in other words, show that C is now the midpoint. Well, we're going to use the fact that B we've just proved is the midpoint. So for part B, all right, we've just proved that B is the midpoint of Ln. So that was proved above. And we know that BC is parallel to NK. And the reason for that is because the whole line segment, your whole AC, is parallel to MK. All right. Therefore, LC must be equal to CK. So we know B is the midpoint. We know that BC is parallel to NK. Therefore, this will only happen if C was also the midpoint of LK. So therefore, LC is equal to LK. LC is equal to CK, and that's because of the midpoint theorem. All right. Okay guys, so far so good. Hopefully you're all following, you're all with me, you understand it, and you're looking at it and thinking, oh wow, this is so easy. I'm going to get 100% in this section, and I hope you do, and I hope you tell us about it as well. All right, last part, part C. They say prove that BC is equal to a half of NK. So prove BC, that one there, is equal to a half of NK. Guys, there's nothing for us to really even prove here because it's just a deduction from the midpoint theorem. So you literally will say your proof BC is equal to a half of NK, and it's literally just a one-liner. So BC is equal to a half of NK, and the reason there, midpoint theorem. Okay, because that's one of the things that the midpoint theorem says, is if you've got a line joining two midpoints of the sides of the triangle, then that line is going to be half the third side of the triangle. All right. Okay, and hopefully you all got those answers. Hopefully you're trying the challenge question, and we're going to get some questions from you. But AB, back to you.
Already I see a lot of questions on the page. So thank you guys, but help one another also on the page, because that's the spirit of Minds. It is hashtag work together. After the break, I'll be announcing our winner, and also get to take you through, guys, our website, because I feel like it was just me and Natasha showing each other the website, and you guys haven't seen it. So if you have seen it already, let me know on Facebook, but we'll see you and tell you about it after the break. Welcome back, Minds. It is now great news. I'm announcing the winner of last week's Test Yourself competition, proudly sponsored by Casio. And our winner is, drum roll please, Natasha.
Dum, da, dum.
Awesome. Apiwe Morgan Makatini, our mindsetter. Congratulations to you, Apiwe Morgan Makatini. This is coming your way. So I know that you're going to need it for your exams, so make sure that you always have it in your case every day at school. But now, let me take you through, guys, to the website that we have. You can see Natasha is having it on the board just to accommodate everyone.
There we go.
Because earlier on, I just had it for myself and you.
Yes.
So one thing I like about the website, nothing really much has changed except that it's more colorful, it's more reorganized, and everything is just on your face. So when you go up, Natasha, like when you really open the page, you get your tabs there on top. When you go to Learn Extra, You see the options that I was talking about? There's Learn Extra Live, there's Learn Extra Lessons, and Learn Extra Revision. Let's go to Learn Extra Live since we're live.
Go, and let's hope that we've got a very fast connection.
Yes, it is. So guys, when you see, it tells you about Learn Extra Live and our shows. Most of you always ask us, when is maths, when is grade 10 maths, when is counting? So guys, just when you open this page, you're going to get to see when is what and at what time. Okay, really, not really at what time, but you're going to get to see that we have grade 10, 11, and 12, and it's always from 4 to 7, meaning grade 10s are at 4, 11, 5, and 12 at 6. But now, go down to on the page, Natasha. This is our schedule, guys. It's very important. It's got the notes, it's got the videos also. The blue ones, it says get notes and then watch video. For all your notes, guys, you need to click on get notes and it's gonna take you through. So let's go to today, Natasha.
Let's go to today.
Yes, down. You check.
Okay,
You just
what's
check on the.
today's date?
It's the
Today's
26th.
26th, the whole day, hey?
Yes.
Okay, there we go.
See, there's
So
grade 10.
There's grade 10 there, yep.
So
That's you and I.
That's us. But you're gonna see on the watch video, it's gray. It means it's not yet there because it's live. So if it's there, you're gonna get it as a red link that you can click on. So let's click on the notes, get notes. Let's show them the notes. Voila. When you click on the notes, you're gonna get to see the notes, guys. But
Which
for
is
the view option,
fantastic.
it's
You can follow at home, hey?
yes. I don't know what's that, Natasha.
We are sorry for any inconvenience.
Don't send
Okay.
anything.
Let's not
coming.
send anything. Yes. We don't know who we're sending
There
it to,
you are.
hey?
Yeah.
There we go.
There you are, guys. So the notes, you just get notes and you'll get the notes. So it's all that Natasha has been doing today, and you've got some questions also there, just to test yourself and see if you're learning with us.
Fantastic.
How nice
we're
is
doing
that?
Today.
Everything we're
is
doing
there.
today. So guys,
Great.
information is there, it's accessible, and also if you go into up last thing, Natasha, very important,
On the notes page.
no, on the main page, on the
Alright,
website.
So let's get out of there. There's the main
Yes,
page.
please go up.
Let's scroll up.
Go on subjects. When you go and click on subjects, you're going to get to see all the subjects that we have, their resources, whether we are doing them live or not doing them live, but you're going to see all of them. Like, as you can see, we've got IT. We don't have a live show about IT, but we do have it on our notes. So it's such a cool website, and past exam papers, there is a link there, and our shop is also there on top there on the link. So if you'd like to buy some of our material, you're more than welcome to go to the shop. It's our online shop. So you can shop there, some DVDs, past exam papers, all our material. It's so affordable, guys. So do check that out also. But I'll post a link to the main website on the page right now.
Great stuff. Well, that's quite a comprehensive idea of what's going on there, Abby.
Yeah, I think I
Now
should be a
everyone knows.
teacher now. Hey, just teach about the website. But now let's get to the challenge question.
All right, guys. So we've got here very quickly, and I hope you're all ready for it. The challenge question for our Monday grade 10s. We were given a triangle that was isosceles. And guys, what I'm going to do is I'm going to show you two ways to do it, because the nice thing about maths is there's always more than one way. So that's why I get really frustrated when some people always tell students that you must do it this way. You know, there's certain sections, yes, definitely, you need to follow the rules. It needs to make sense. But there's more than one way to get to the answer by using the correct rules. And really, if you use the correct rules, the correct deductions, correct theorems, you will get marks for it. So there's not just one way to do maths, and that's what's so great about the subject. All right. We know that PQR is an isosceles with PR equal to, let's just get our pen up after all that website pointing. We know that PR is equal to RQ. And S is the, okay, and then they tell you all these little points. S, U, and T. Those are the midpoints of all the lines that they lie on that triangle. All right? Question straightforward. It says, prove that STU, which is the triangle in the middle, prove that that is isosceles. Now, the way to prove that a triangle is isosceles, well, guys, you know, what is an isosceles triangle? It means that two sides of the triangle are equal, and that means that the base angle, so the angles opposite those sides are equal to each other. So when they told us that PRQ was an isosceles triangle, and they told us that PR was equal to RQ, that straight away told us that angle Q was equal to angle P. All right, because remember that's what happens in an isosceles triangle. Your opposite angles are equal to each other. All right, your angles opposite the equal sides. Okay, so if we're trying to prove that STU is isosceles, really what we want to show is that any two sides, any of these, okay, we don't know which one yet because we haven't actually started the question, but any permutation or any combination of those sides is equal to each other, right? So that's our aim. We need to prove that any two of those sides are actually the same, all right? And we seem to have lost the pen here. There we go. Okay. So as I said to you, I'm going to show you two different ways to do it. Let's start with the midpoint theorem way, because that is our subject for today, is just using the midpoint theorem to show, to apply it to certain questions. So I'm going to show you the midpoint way, and we are going to use the midpoint theorem even with the alternate proof that I will show you. All right. Okay, so we know PR is equal to QR, and we have all of our midpoints given. Okay, we know that T, S, and U, those are all the midpoints. Okay, now what we also deduce from that, we don't know if we're going to use it, but the deduction we make is that TU is parallel to PU. We also know that that means if T is the midpoint, U is the midpoint, obviously TU is parallel to PQ, right? Similarly, TS will be parallel to RQ. And then we also know that SU will be parallel to PR. Okay. Also, from our deductions from midpoint theorem, SU is going to be a half of PR, ST is going to be a half of QR, and UT is going to be a half of PQ. So we've got quite a few lengths that we can reason with and work with here. All right. So if I look at side ST, okay, let's do that in a different color. Let's look at side ST. We know that ST, right, is a half of RQ. Why do we know that? Why can we make that statement? Because that's what the midpoint theorem says. Okay, so ST is equal to a half of RQ. Okay. Also going across to the other side, I know that side SU, that one in green, is equal to a half of side PR. Right, so SU is equal to a half of PR. Again, that's because that's what the midpoint theorem says. So we've got ST is a half of RQ, we've got SU is a half of PR. But guys, what do you know about PR and RQ? They told you in the beginning, they told you that PQR was isosceles with PR equaling to QR. So really, I can replace QR with PR, or I can replace side PR with QR. So following from there, I can say therefore ST is equal to a half of PR, and as I said, I can replace either one. Why can we do this replacement? Why can I change QR to PR? Simply because RQ was equal to PR. That was given to you because that was an isosceles triangle. So now we know that ST is a half of PR, but hang on, SU is also a half of PR. So therefore, our deduction, ST must be equal to SU because they both equal a half PR, right? They're both equal to a half of PR. So therefore, those two sides are actually equal to each other. But now, if you look at ST and SU, they're equal to each other. They fall within triangle STU. Therefore, we've proved ST equal to SU. So what kind of triangle is that? Therefore, triangle STU is isosceles. All right. Hopefully you guys got that. I know it's a kind of a difficult thing to send the answers through on the Facebook page because you've got to write out the entire proof, but hopefully some of you were able to write out this proof, AB, and send us their proof.
I've seen some writing it,
Yeah.
and I think there's one that got it right.
Fantastic.
Ovi Mutali got it right, and other mindsetters also, but some were just saying, yo, this is so difficult.
Not what we want to hear. Geometry, this midpoint theorem is not difficult. If you don't like this way, I'm going to show you another way. So this way, I simply used application of the midpoint theorem, where we said, you know, the line joining the midpoints of two sides of the triangle is a half the third side of the triangle. So I'm going to show you again what I did here, but after that, I'm going to do an option B. So for you who don't see, because remember, geometry is a very spatial thing. It's like those 3D puzzles. Not everyone sees the same picture, and that's why you can get to the same answer, though, in different ways.
So
Okay.
true, Natasha, just to get on you on what you just said now, a lot of other mindsetters on the question itself were saying they can't see it also. So it's something that
It's very
saying.
spatial. It's like those 3D puzzles that they used to put on Astros boxes. All right. So what I just did here was I just used the midpoint theorem, and I showed that ST was, let's do it in even more color because we love color. I showed ST was a half of RQ. I also showed SU was a half of PR. But because PR was equal to RQ, it meant that SU and ST were a half of the same length. So therefore they had to be equal to each other, and that triangle was isosceles. So that's what I just did there. An alternate for those of you who cannot see that, let's take everything off here. Okay, so for you guys who can't see that way, let's do another method, all right? Again, working with the same triangles, PR is equal to RQ. Because it's an isosceles triangle, remember the rules you learned from grade 8, isosceles triangles, the angles opposite the equal sides are equal to each other. So angle P is equal to angle Q, all right? From the midpoint theorem, guys, using the same parallel lines, right? I know PQ is parallel to TU, okay? That is straight from the midpoint theorem. And then you had all those other parallel lines, which I'm simply going to write down again. Okay, and that was all straightforward application from the midpoint theorem. All right, so you had all of those lines being parallel to each other because they were joining midpoints of the sides of the triangle. All right, going back to the angles now. I know PQ is parallel to TU. PQ is parallel to TU, right? Therefore, that brings into effect all of those nice angles we know. Hopefully you can see in green the F shape. That would mean that this angle P is equal to angle T, because those lines are parallel and therefore they form corresponding angles. Okay? Similarly, angle Q is equal to angle U. Why? Same reason. PQ parallel to TU, angle Q and angle U are corresponding angles. All right, guys, so you can see those corresponding angles, okay? But we want to get inside of triangle STU. How are we going to do that? Well, we know that this line segment PR is parallel to SU. Okay, you can see that in the Z. Therefore, this angle T, right, will be equal using alternate angles. Angle T will be equal to this angle there, angle SUT. Those two are equal to each other, right? Similarly, Let's use a different color now. Similarly, we know that ST is parallel to the whole line segment RQ. So therefore ST is parallel to RU. And if we look at this angle here, angle TUR, that angle there, that is now using alternate angles going to be equal to angle T. So therefore you've got these two angles now equal to each other because they're equal to two other equal angles. So another way to prove the same thing. Those two angles are equal, therefore it implies that the sides opposite those angles must be equal. So therefore ST is equal to SU, which means once again we have an isosceles triangle. All right, let's set that proof out, guys. So this is option 2 if you didn't like the first one. All right, so what do I start by saying? Well, we know that angle P, okay, and it's important to name your angles correctly, because if I just say angle T, right, we've got 1, 2, 3 different parts that make up angle T, so we need to name that angle correctly. Angle P, it's fine to say angle P because there's no other angles branching out from there, all right? Angle P is equal to angle UTR. And the reason for that, PQ is parallel to TU. Okay, so those are corresponding angles. How did we get PQ is parallel to TU? Well, that was because of the midpoint theorem. All right, so angle P is equal to angle UTR. Angle Q is equal to angle TUR. Remember, the one in the middle is always the angle reference that we are referring to. Again, for the same reason, the same lines are parallel. Again, it's corresponding angles. So therefore, if P is equal to Q, and Q is equal to that angle there, and then P was equal to that angle there, it implies that these two must be equal to each other, right? So therefore, we know, therefore, deducing from what we've just said, that means that UTR must be equal to TUR because they both equal each other, because angle P is equal to angle Q. So it's just a deduction from what we've said so far. All right. Then we can say that angle UTR. All right, again, I'm going to take all of this out because it becomes confusing when there's so many different colors. But what I do suggest to all students is that you use color when you're dealing with geometry, because it makes it so nice and so simple to see what's going on. Try not to use pen because it's not as easy to erase like I've just done, but in pencil, write down what you've got. Write down your given information and what you're asked to prove. All right, so what am I saying? I'm saying that UTR is equal to RUT, or TUR, okay? We also know that angle UTR is equal to, all right, and I need to keep the diagram up and this at the same time, so I'm going into the question itself, but UTR is equal to, by alternate angles, it's equal to angle SUT. And the reason for that, alternate angles, and we know that SU is parallel to TR. Okay? Those two are equal. Similarly, we swapped around. We said that angle CUR, all right, TUR, that one, that was equal to angle STU. And the reason for that, alternate angles, and the sides that were parallel then, it was ST and UR. Okay, you don't have to say UR, you can say ST parallel to QR. I've just abbreviated the lines, but it's the same thing. Okay, so angle TUR is equal to STU. There we go. And therefore, what have we said in everything that we've written down? We have proved that this angle here, that whole thing there, that must be equal to that whole thing there, right? That's what we've just shown in all of the reasoning, okay? So therefore we can say, from what we've just shown, angle STU is equal to angle SUT, right? That's what we've shown, because they're both equal angles, all right? That's the deduction from what we've just shown. So therefore, triangle STU is isosceles. Okay, because they are the sides opposite your equal angles, so therefore those two must be equal. All right, so I've kind of labored the question and I've gone through it more probably than I should, but hopefully that you guys will get it now and you understand more than one way to skin a cat. In both of these proofs, option 1 and option 2, we still had to use the midpoint theorem. And I've skipped over writing down every single step, but guys, remember, when you do your proofs, you need to write every step. You need to say, why was, for example, TU parallel to PQ? That was because of midpoint theorem. You need to write down all of those steps with your deductions. All right. Do we have some questions?
Yes, some questions and comments from the visitors, especially this one that just came in now from Junior saying, nope, nope, nope. Option 1 is better. Hey, I understand the first one.
I think it's also easier. Personally, I also think it's easier.
All right, here's a question from Lungelo saying, how do I know if the lines are parallel in triangles like the one of the challenge question?
How do you know the lines are parallel?
Yes.
Okay. Well, guys, remember, for this question, right, they gave you one of the midpoints. So they told you, all right, look at what they said. They said PQR is an isosceles triangle. They told you which sides were equal to each other. Fine. They also, very importantly, gave you a midpoint. Okay? They said that S is the midpoint of PQ. T is the midpoint of PR. So if we just look at those two, S is the midpoint of PQ, T is the midpoint of PR. If we join those two together, the midpoints of two sides of the triangle, the midpoint theorem tells us. So how do you know which lines are parallel? From the midpoint theorem. It says, that's why you need to understand that theorem, study that theorem, make sure you understand what it looks like in your head. It says that if there's a line joining the midpoints of two sides of the triangle, then that line, in this case ST, is going to be parallel to the third side of the triangle. The third side, meaning the side that's not included in the midpoints. Okay? So ST is parallel to QR, and it also goes on to say that that line, ST, will be a half of QR. All right?
Okay. Right, let's go to another question. There's a question by Timusho saying, on example B, why did we times by a half? On example B, I think question 2.
Okay, so this is question 2. Let's go back there. Part B. All right, I don't think it means example 2, because there we didn't times by half. We just had to say LC was equal to CK.
Maybe if I read you the answer from one of the mindsetters, you relate that with the question. Though the mindsetter said they still don't get it. The answer to that was so that you can... Okay, you see, even the question, I also don't understand it. So that you can see that particular half of that number to get the other side being equal to the length of the third side.
Okay, what I'm going to do is I'm going to go right back to our examples, and I'm going to show you how we get that the one side is twice or half of the other side. I think that might clear it up, because it all sounds like everyone's just getting a bit confused over about what's parallel, what's a half, and so on. So if we go back to example 1b, okay? All right, and here we had this triangle where we were given the midpoints. Again, I'm going to erase everything and just start again here. Okay. You were given the midpoint, let's just call this A, B, C, and let's call that D, E. Okay? You were given that E is the midpoint of AC. How do we know? They put those little symbols or little, whatever you want to call them, strokes, to show that that's the midpoint. So AE is equal to EC. You were also told that D is the midpoint of BC, again by those symbols there. Straight from the application of the midpoint theorem, it says the line joining the midpoints of two sides of a triangle. So that line in this case will be ED. It joins the midpoint of the two sides of the triangle. That line will be parallel to the third side. So ED is parallel to AB. And that line, ED, is going to be a half of AB. I didn't make that up. I didn't prove that. I didn't show that. That's just what the theorem says. So that's just a straightforward, just really a statement. Okay, so the theorem says that this line ED is going to be a half of AB. Therefore, from the midpoint theorem, if ED is a half of AB and AB is 7, it means that ED must be 3.5. 7 divided by 2.
Awesome. Thank you, Natasha. Unfortunately, we've run out of time.
All right. So hopefully everyone is understanding now and you guys are on the right track to learning the midpoint theorem.
Indeed, just like Mika is saying on Facebook that he enjoyed the lesson and he can't wait for the first period tomorrow. I hope it's the same as you, my sisters. Remember to get the notes. But from us, we just want to say we appreciate and we love you. Grade 10 Mind Sisters. Peace.